Hello guys, welcome back to the channel. Today we will be doing the part 3 of the chapter motion of class 9, which is the exercise question. So stay focused. We will be completing all the 10 questions of the chapter motion in class 9. So earlier in two parts we have done the full summary and the in-text questions. So let's start. So the first question is, an athlete completes one round of a circular track of diameter 200 meter in 40 seconds. What will be the distance covered and the displacement at the end of 2 minutes 20 seconds? So we have to find out the displacement the athlete will cover in 2 minutes 20 seconds, as we have been given the diameter. So let's start. First of all, we'll write the given are diameter of the track, that is D, which is given as 200 meter. Then therefore we have to find the circumference. So circumference of the track, which we will get by the formula pi into d, which is pi into diameter, which will be, this is the diameter multiplied by pi meters. Now they have given the distance covered in 40 seconds. So the total distance is distance covered in 40 seconds, which is 200 pi meter. And so now the distance covered in 1 second will be 200 pi by 40. So as we know, one round is covered by in 40 seconds. So now we will find out the answer. So now the distance covered in 2 minutes and 20 seconds, which is 140 seconds. 140 seconds will be 140 multiplied by 200 pi by 40. Now this will be equal to 140 into 200 into 22 divided by 40 into 7. How did we get the 22 here and the 7 here? This is the value of pi, which is 22 by 7. So the answer we get is 2200 meters. Now number of laps completed by the athlete in 140 seconds is 140 by 40, which is 3.5. So therefore the final position of the athlete is at the opposite end of the circular track. Therefore the net distance will be equal to the diameter of the track, which is 200 meter. Therefore the net distance covered by the athlete is 2200 meter and the total displacement of the athlete is 200 meter. So therefore net distance is equal to 2200 meters, and the total displacement is 200 meter. Now the second question, it is asked here, Joseph jogs from one end A to the other end B of a straight line 300 meter road in 2 minutes 30 seconds. So Joseph jogs from point A to point B in 2 minutes and 30 seconds, which is 300 meter distance, and then turns around and jogs back 300 meter to point C. So again he turns around and goes back to point C, and which is 100 meter, and 1 more minute is added. Okay, so what are the Joseph's average speed and velocities in jogging from A to B and from A to C? So we have to find out the velocity and the speed from jogging A to B and from A to C. So first of all, we will always write the given. Here the given is distance covered from point A to B, which is 300 meter. Then distance covered from point A to C, which will be 300 plus 100, which is 300 plus 100, which is equal to 400 meter. Now time taken to travel from point A to B, which is 2 minutes 30 seconds, which is equal to 150 seconds. Now same time taken to travel from point A to C, which is 150 seconds plus 1 minute, which is equal to 210 seconds. Now displacement from A to B, which is 300 meter. This is also the distance and displacement both. Now displacement from A to C. Remember, these two things had happened in the same line. Okay, so this C will be here. Now the displacement from A to C. A to C is 300 meter minus 100 meter. This is 100 meter and this total is 300 meter, which is equal to 200 meter. Now the formula of average speed is equal to total distance traveled by total time taken. Then the formula of average velocity is total displacement by total time taken. Now, therefore, the average speed while traveling from A to B will be total distance traveled by total time taken. The total distance was 300 from A to B, and the time taken was 2 minutes 30 seconds, which is 150 seconds. So this will be 2 meters per second. Now here, average speed while traveling from A to C will be same total distance traveled by total time taken. The total distance from A to C was 400 and the total time taken was 210 meters, which is 1.9 meter per second. Then average velocity while traveling from A to B will be total displacement by total time taken. This will be same 300 by 150, which is 2 meter per second. Then again, average velocity while traveling from A to C, which will be 200. The displacement is 200 and the distance is 400. Okay, the distance, the displacement by total time taken, the total time was 210, which will be 0.95 meter per second. So in this question, which we have been asked about the total speed, the average speed and average velocity, we have found out the answers for both A to B and A to C. So the next question is question number 3. It is asked here, Abdul, while driving to school, computes the average speed for his trip to be 20 km per hour. On his return trip along the same route, there is less traffic and the average speed is 30 km per hour. What is the average speed for Abdul's trip? Okay, we have to find out the total average speed of going to school and coming back from school. Okay, so let us take this as home, which is A, and this is his school, which is B, and let us take this distance as L. Okay, so while going from home to school, he drives at a speed of 20 km per hour. On his way back, he comes at 30 km per hour because of less traffic. So here time is not given, so let us take T1 from going home to school will be the total distance traveled, which is L, by the time taken is 20 km per hour. Okay, then again let us take T2 from traveling from school to home, which is the total distance L by time, which is 30 km per hour. Okay, now we have to find out the average speed for Abdul's trip. Okay, so total average speed of Abdul's trip will be total distance, which is 2L by total time taken T1 plus T2. Okay, now this will be 2L and T1 is equal to L by 20 plus T2 is equal to L by 30. Now let us take this L as 1, this will become 2, and this will become 1 by 20 plus 1 by 30. Now this 20 plus 30 will go up like this, 2 into 20 into 30 by this will be get added, 20 plus 30 which is 50, this 0 gets cancelled, 4 5 4s are 20 which is 24 meter per second. So this is the total average speed of Abdul's whole trip, okay, which is 24 meter per second. Question number 4. It is asked here, a motorboat starting from rest on a lake accelerates in a straight line at a constant rate of 3 meter per second square for 8 seconds. How far does boat travel during this time? So we have to write the given. Acceleration is given, which is 3 meter per second square. It is also said that the boat is starting from rest, which means initial speed is 0 meter per second and the time given is 8 seconds. Okay, now we have to find out speed. How far does the boat travel? So we have to find out the displacement traveled by the boat. So as we can use here the second law of motion, which is S equal to ut plus half at square. Okay, as we know u is equal to 0 and t is 8 seconds, so 0 into 8 will be 0, so we'll be doing it from here. Half a is given as 3 and t is given as 8, so 8 square will be 64. This get here, so this will be 3 into 32 which is 96 meters. So the distance traveled by the boat during this time is 96 meters. So the next question, which is question number 5, here it is asked that a driver of a car traveling at 52 km per hour applies the brakes and accelerates uniformly in the opposite direction and the car stops at 5 seconds. So let us take that a car is traveling at 52 km per hour and the driver applies the brakes and it stops in 5 seconds. Okay, now another car which is going at 34 km per hour and it also applies brakes slowly and stops in 10 seconds. So the second car is moving at 32 km per hour and stops at 10 seconds. So on the same graph paper, plot the speed versus time graph. So let us plot the speed versus time graph. This is the speed and this will be the time graph. So let us take the speed of car A, which is 52 km per hour. Okay, and it stops at 5 seconds. So the graph of the car A will be like this. Okay, this is the speed versus time graph of the car A. Now for the car B, which is traveling at 34 km per hour, stops at 10 seconds. So now this will be the graph of the car B, which stops at 10 seconds. Now it is also asked which of the two cars travel further after the brakes were applied. So as we know, to find out the distance traveled by any object or anything, we have to find out the displacement under the curve. So we have to find out the area under the curve, or the area of this triangle for A, and for B we have to find out the area under this triangle. So let us find out. So now let us find out for A, which is, let us take as A will be half into base into height. So base is 5, this is 5, and height is 52. So 52 goes down and here comes 26. So 5 into 26 will be equal to 130. This will be kilometer by hour per second. Okay, then SP will be equal to same, half into 10 into 34. This will be 17. So 10 into 17, this will be 170 kilometer by hour seconds. Okay, so from here we have come to know that therefore SP is greater than SA. So car B has traveled greater distance after brakes were applied. Okay, this is a easy, guys. Don't get any tension in this question. These questions are really very easy. Just stay focused and always look for a new angle to solve these questions. Okay, so the question number 6, here it is asked in 4 parts. So it has given us a distance time graph of 3 objects, which is A, B and C. So study the graph and answer the following question. So the first question is, which of the 3 is traveling the fastest? So number A, for traveling the fastest, speed have to be maximum, which is dx by dt. That means the slope having the maximum raise will be the fastest. So here we can say that the slope B, or the object B, is traveling the fastest. So in part B, it is asked that, are all 3 ever at the same point of the road? So if you see in the graph, you will see that the object A and object B meets at the point D, but the object C meets B at the point F at different point of time. So the answer will be no, all 3 do not meet at the same point on the road. Now the part C, it is asked that how far has C traveled when B passes A. So if you see in the graph, when the B and A meets at a point at the same interval of time, we can see that the C has traveled 7 kilometer, I think approximately, when B passes A. So the answer will be C has traveled 7 kilometer approximately when B passes A. The fourth question, it is asked that how far has B traveled by the time it passes C. So if you look at the graph, you can see that by the time when the object C passes B, it has traveled approximately 4.25. So the answer will be B has traveled 4.25 kilometer approximately when C passes it. Okay, these are the four answers of the four questions of the question number 6. Now question number 7. In this question it is asked that a ball is gently dropped from a height of 20 meter. It means the ball is dropped from a height of 20 meter if its velocity increases uniformly at the rate of 10 meter per second, which means acceleration is also given. With what velocity will it strike the ground? So here initial speed is 0 meter per second, then speed is distance is 20 meter, acceleration is 10 meter per second square, and we have to find out velocity, which is v. So if we use this in the third equation of motion, which is v square minus u square is equal to 2as. Now v square minus u square will be 0, and this will be 2 into 10 into 20. Now this will be v square equal to 400. Now here v will be equal to 20 meter per second. So this will be the velocity of the ball striking to the ground. Now the second it is asked that after what time will it strike the ground. So we have to find out t. So to find out t, we have to use the first equation of motion, which is v is equal to u plus at. So in this, v is 20, u is 0, and at will be, a will be 10 and t will be 10. So now finding t will be equal to 20 by 10, which is equal to 2 seconds. So here time will be 2 seconds. So this is the second requirement of the question, which is asked after what time will it strike the ground. So after 2 seconds the ball will strike the ground. So now the question number 8. So in this question it is shown here a speed time graph. So from first the number A, it is asked find out how far does the car travel in the first 4 seconds. Then shade the area on the graph that represents the distance traveled by the car during the period. So as we can see, I have drawn the graph earlier, so it will be easy for you to understand. So let us solve the A first. So the shaded area represents the displacement of the car over a period of 4 seconds. So because in the question it is asked that find out how far does the car travel in the first 4 seconds. So we'll be answering this as the shaded area represents the displacement of the car over a period of time. Okay, period of time, which is 4 seconds. Now it can be calculated as 1/2 base into height. What is base? Is 4 and the height is 6. So it will be 12 meters. So therefore the car travels a total of 12 meter in first 4 seconds. Now I also shaded this area. Okay, now the question number B, 8b, which is said which part of the graph represents uniform motion of the car. So here we can see that from 6 to 10 we can see this is somehow a straight line which represents the uniform motion of the car or the uniform speed of the car. So here will be, since the speed of the car does not change from the points which are x equal to 6 and x equal to 10. The car is said to be in uniform motion from the 6th to the 10th second. Okay, as the shaded area represents the displacement of the car over the period of 4 seconds, then we have calculated the area under the curve, which is half into base into height. This is 12 meter. So therefore the car travels 12 meter in the first 4 seconds. And since the speed of the car does not change its position or the speed from the points x equal to 6 to x equal to 10, so the car is said to be in uniform motion from 6 to 10th second. The next question, which is number 9. In this question it is asked that state which of the following situations are possible and give an example for each of these. Okay, so A, it is said that an object with a constant acceleration but with 0 velocity. Will it be possible? Yes, it is possible. Okay, so we have to give an example that an object thrown up into the air has a constant acceleration due to gravity acting on it. Okay, you got this? Now, however, when it reaches its maximum height, its velocity is 0. Okay, it is possible that an object with a constant acceleration but with 0 velocity. Then number B, it is said that an object moving with an acceleration but with uniform speed. Is it possible? No, it is impossible. How? As we know, acceleration implies an increase or decrease in speed. Okay, acceleration implies it can be implied as increase or decrease. Acceleration can be positive or also can be negative. And uniform speed implies that the speed does not change over time. Uniform speed means it is always in the same direction and is always positive. Number C, an object moving in a certain direction with an acceleration in a perpendicular direction. Is it possible? Yes, it is possible. How? For an object accelerating in a circular trajectory, the acceleration is perpendicular. The acceleration is perpendicular to the direction followed by the object. Okay, so the 10th question, which is the last question, it is asked that an artificial satellite is moving in a circular orbit of radius 42250 km. Calculate its speed if it takes 24 hours to revolve around the earth. So first of all, we write the given. The given is radius of the orbit, which is 42250 km. Now therefore we have to find the circumference of the orbit, which will be 2 pi r. 2 into 3.14 into 42250. Always remember pi value will be 3.14 or 22 by 7. Now this becomes 265,571.42 kilometer. So now time taken is also given. Time taken for the orbit is 24 hours. So now we have to find out the speed. So speed will be this one as circumference by time, which will be 626,571.42 by 24 hours. Okay, now this is kilometer by hours. Now this will be, we will get as this, which is 11065.4 kilometer per hour. So the satellite orbits the earth at a speed of 11065.4 kilometer per hour. So thank you guys. Here we end our chapter 9 of class chapter 8 of class 9, which is motion. This is the third part or the third video in which we have done all the exercise questions. So please guys, do subscribe, like and share with your friends. This is completely necessary, so you can help yourself and help others. Follow me. I will be there after every 2-3 days with a new video, with a new chapter. Hope you are safe at home. God bless you.